Hey, this is Steven from LegitTechTutorials and the Green Engineers. So, this video is talking about my next series of product design tutorial series. So, I'm going to be working on a new product for the Green Engineers, my company, my small business, the Green Engineers. And I'm going to start designing and build a shredder that will be launched on Kickstarter. So, I'm going to be building a shredder that will be able to shred plastic, so that it's mainly designed to shred plastic, and then the plastic is going to be used in the multi-shear and other designs I come up with later. So you shred the plastic into flakes, into certain size flakes, and then you put it inside the hopper of the multi-shear, and you basically extrude the recycled plastic. So the design is going to be similar to the design that the guy behind Filmmaker has done. So here are some of the pictures from Google Images of the design of the Filmmaker shredder. So it's going to be similar to these designs here. I'm going to make a few adjustments. One being that it's all going to be plate. So, like, this is his organic shredder, which is really nice. Similar to this where it's all plate. So, what type of manufacturing am I going to do on it? It's all going to be cut on either a plasma, a YAG laser, or a water jet. So, Tech Shop San Jose has a water jet and not a plasma, not a YAG. They have some low wattage, 60 watt CO2 lasers. Definitely not going to be able to cut the type of plate I'm looking at. But yeah, so it's going to be, I'm going to be designing it around the water jet, which is a very expensive machine. It's a gigantic machine. It's about a $300,000 water jet. And the issue with the water jet, one of the constraints of the design. So this video is just going to be talking about some of the constraints of the design. We're not going to be designing on this video. So if you want to skip to when we start designing, you can skip to the next video. But the design is going to be constrained around the time it takes to cut, because the water jet is extremely costly per time. So you have pumps on there that are going up to 60,000 psi. So that requires a lot of energy to compress water and sand to that psi. So it is very, very expensive to have that type of flow and compression running at once. That type of mass flow as well as compression. So at Tech Shop San Jose, they charge you $3 a minute for cutting. So you have to design around having the quickest cuts possible. And also, but you still want to have the point where you're going to balance how much time you're cutting compared to how much work you're going to do assembling or doing other things on other machines. So I want to do the complete opposite of what I did for the multi-shooter. The multi-shooter was mainly hand-built. It had, it had a lot of human interaction in the manufacturing process. So I was working a lot on putting it together and stuff like that. So a lot of the stuff I welded, and everything was kind of like, if it was off a little bit, I had to go in and make the adjustments to make sure everything was straight and plumb, and then welding a whole bunch of stuff everywhere, and it took a lot of time, and then painting and stuff like that. It took a very long time. So this project, the shredder, which as far as right now, there is another product that has a similar name, so I don't know if I'm going to go with this name, but it's going to be with the original name the multi-shooter was, which was the Reclaimer. So the name of this project is going to be the Reclaimer. It's going to be going through Kickstarter, 30-day Kickstarter, and I want to try, it may sound crazy, because now it's October 22nd, 2016, but I want to launch it by November 17th, and have a month, and have it over by December 17th. And then 15 days to get the money. So by the time I get the money, I'll be in my winter break, and my winter break's a month long, and I'll be able to work on it throughout the winter break. So yeah, so again, we are constrained around the time it takes to cut, and also by the manufacturing process. So that limits me to only using plate. So all this design has to be 2D and then assembled into 3D. So as you see here, most of this stuff can be done that way. So the only thing is that I probably won't do any sheet metal. It'll all be the same size plate. I won't vary the plate thickness. So every time I vary the plate thickness, I have to buy another sheet of plate that is not exactly in the same bulk. So it's all going to be in the other constraint is the constraint of the thickness of the blades. So the thickness of these shredder blades. So now, in order for the flakes to get into the multi-extruder, they need to be about a 1/4 inch or so. I have my calipers over here. They have to be around, they have to be at least less than 1/2 inch. So it's either going to be 1/2 inch or a 1/4 inch. So I probably don't want to go 1/2 inch because that's really heavy plate, and I would have to, and Tech Shop San Jose right now is in some financial troubles, so I don't even know if they're going to be there by January. So I might even design this and then not have a machine to build it on, and then I have to outsource it to somebody else to build it on, because Tech Shop's in dire need of funding right now in order to get their new location up to speed, up to code, in order to move in. So if they don't get the money to bring the other location up to code, they're going to be kicked out by the end of this year. And then early next year, they're going to be kicked out of this current location, and the new location is not going to be up to code, so they're basically going to be homeless, or shopless, I guess you could say. So if that's the case, I'm not going to have a water jet to use, or a shop to build it in, or a shop to store it in, blah blah blah. So I would possibly have to outsource it, but similar, using laser, yeah, and also on the new location, there's only like a drop-off point where you can pull your truck up and unload all the stuff and then store it. So I would prefer not to have to carry 1/2 inch plate. 1/4 inch plate is probably the thickest I want to go, because 1/2 inch plate is going to be very difficult. And it's not just like plate. It's probably like going to be big plate, like I don't know, 12 inches, foot, or a foot by extremely long. So I'd have to carry that out of the truck, and then be able to get it on the water jet bed, the water jet cut area. So that's another constraint, is the weight and how I'm going to get it back into a place where, back to the water jet and cut it. Because I would like to do everything without you asking them to use the forklift. So, yeah. So I want to limit on weight, because it definitely hinders the moving stuff around and stuff like that. So definitely want to think about that. So yeah, make everything out of 1/4 inch plate. So all these blades will be 1/4 inch. All these guys here would be 1/4 inch, 1/4 inch, 1/4 inch. This is 1/4 inch. This is 1/4 inch. And maybe even do the gears on there as well. I'll probably just do everything 1/4 inch, 1/4 inch, 1/4 inch, 1/4 inch. Everything 1/4 inch. Because I mean, this decreases the area of the meshing, but if you go 1/4 inch, but then I don't need to outsource the gears. So the idea is that and then the rod, there's a rod that goes through here, that goes through the cutting wheels. The cutting wheels are, most of the time they're hex. There's six corners, hexagonal cut, so that they have a hexagonal shaft that goes through. But I can't just go down to my local metal supplier and get a hexagonal shaft or a hexagonal rod. So what I'm going to do is I'm just going to use solid square rod, because I could buy that pretty much anywhere from the place that I'm going to source this from. So a lot of this stuff is going to be local and not exactly. And also another thing is that it's very difficult. Or you could use these. use Allen wrenches, sure, or hex wrenches, I guess you could call them. You could use hex wrenches also, but I'll probably just use not quarter inch, just a square rod, and then I might even need to have it hollow. So when I say have it hollow, that brings up the next constraint, and that constraint is all of the I'm gonna also use the flat rate boxes, design my machine around the flat rate box. So this time, instead of the multi-extruder, which I had a lot of issues with things getting there damaged and stuff like that, I'm not really worried about this one too much, as this is all steel, no electronics. So what I'm gonna do is I'm gonna use the medium flat rate box. So that means that this unit, the standard unit, is gonna be 6x6. So 6x6, and then that would mean that in order to be 6x6, it needs to have 3-inch tall, around 3-inch tall diameter here. So that means that it's 3 inches tall. So 6x6 by 3 inches. So that will fit in the medium flat rate box pretty well. And then what I'm going to do is I'm going to put that medium flat rate box inside the large flat rate box, and then fill that full of pellets. So that way it's going to protect this as much as possible. So of course it's going to cost me an extra $4. Medium flat rate box is $11.58, something like that. Large flat rate box is $14.86, something like that. And then another constraint is that in order to do international flat rate box, it needs to be under 20 pounds. So I need to get a 6x6 almost solid steel shredder under 20 pounds, which the multi-extruder right now was 17 pounds. And it had a little bit of electronics, but it did have heavy pipe and stuff like that. So I might need to do some other design work where these wheels are like rims, where I cut some stuff out of it, or I cut some stuff out of these. So I start removing some material, which will add cutting time, machining time, so that adds 3 minutes, $3 per minute, and that reduces strength, but that will reduce weight, and might allow me to ship international. So the constraints are 6x6, at least, and I think it's 5 tall or 4 tall, but this is going to be 3 tall. And then 6x6 by 3. The next constraint is, so under 20 pounds, 6x6. Next constraint is using all 1/4-inch plate, and everything has to be designed in 2D and then be assembled in 3D. Cut a water jet, so like I said, 2D. All made out of the same material, same size plate. That is pretty much it as far as the constraints. So like I said, I'm going to try to have this completely different than the multi-extruder, where this is about 95% machine cut, and then I assemble about the other 5%. So by the time the next one's cut, I'll have the previous one assembled. That's the idea. So that way I could, if there's a whole bunch that were ordered, I could fulfill that entire order during the winter break, which is 1 month. So I should be able to build this whole thing in 1 month. The only thing that it's going to need, that I know for sure, online from China, also I want to try to have as few components outsourced as possible. A few things I'm going to need from China. Number one is the flange bearings. That's pretty much it. So the flange bearings. I'm not going to be able to make those myself. So yeah, hopefully that's the only thing sourced from China. Another thing is it's going to have a possibility for a motor, and then another, so that would be an add-on, because right now I'm really worried about the liability here, like somebody stick their finger in there. So what's going to happen is this guy is going to come with a ratcheting, with a long, like a torque wrench ratchet, not a torque wrench, but yeah, sure, I guess you call it a torque wrench, or a breaker bar, like a ratcheting breaker bar. So that way I leverage the fact that humans try to not hurt themselves. So if you have your finger stuck in there, it starts to crush it. You're not going to keep going on the ratchet to crush your finger, generally speaking. So that way it will keep you from hurting yourself too bad. So similar to this. So if you get your finger stuck in there, you're not going to keep cranking on that. And then in order to get the motor, you'd have to buy the housing that would bolt onto something like that. Or in this case, it would just bolt onto the side probably. So I don't have to, this is obviously a 3D shape. So just bolt onto the side, and you would have to bolt the motor onto the cover or the funnel, right? So you'd have to bolt the motor onto the cover. So that means that in order to get this whole thing to work, you do have to put the shroud on in order for it to work, because you can't just bolt the motor up here and then just not put the shroud on. So I'm going to have it to where it forces you to put the shroud on in order to get the motor to work. So if you get your finger in there, it doesn't rip your finger off. And it doesn't rip your finger off and just keep going. Next thing you know, your arm's gone. Next thing you know, your elbow's gone. Next thing you know, your shoulder's gone. And just keep going. Because this guy, hardened steel will definitely go through your bone pretty easily. And cartilage and stuff like that. Oh, there you go. There's a good view of the hex. So mine's probably just going to be square. So from here to there, here to there. So I could fit a square bar or square tube through there. And then whether it would be tube or bar will depend on how much weight I need to shed. Another thing, how many teeth is it going to have? It'll probably just have 2 minimum, maybe 4, because like I said, the more of these details where it comes out, the more kind of circumference you have, the longer the print time. And the idea is that if it's hand cranked, you kind of don't want these to be hitting as often, so that way you use less torque to cut through, so you're not cutting through multiple parts of the piece at once. You only have, so here you see that it has 2 blades cutting at once. So instead of just having 1 blade, so having them rotate evenly, especially with this big of a piece, is similar to this. This is a Filmmaker's organic shredder, and it should have, with this size, it should have something like 14 blades. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Ah, good guess. Because they're 1/4 inch, so you can do the calculations on that. 1/4 inch and 4 quarters in an inch. So 4 times 6 is 24. That must be a lot smaller then. Or these are bigger blades. One of the two. But mine's going to need quite a few. It's going to need quite a few blades in order to fill up that. Because the idea of the shredder is that these blades mesh together, and then it meshes in between the next one. So the idea, and they alternate. So you could think of them just as a long tube and how long you need it to go all the way across, and you count it in quarters because it's the size of blades. I might up the size of the blades to maybe lower the speed to lower the time it takes to put it together, to cut it out. But that increases strength, but it increases time it takes to cut it, and it decreases strength. So hopefully it doesn't decrease the speed too much. Hopefully it's actually an increase in speed and time and decrease in time it takes, because it's not. If you double in size, maybe you don't necessarily double in time it takes to cut. I don't know. Maybe it's a lower scaler. Who knows? Alright, so I've been talking about this a little bit. Let me see, anything else I need to talk about? So yeah, kind of like this, how you see them kind of progressive. See that? See how they're progressively wrapping around? You got this little pattern here. That's what mine would be like, so that only 1 blade is engaged at once, and then the second blade engages, and the third blade engages, and the fourth blade engages. Here's another idea here. It's another type of design which is similar to this design. Alright, well, that is pretty. Oh, here you go. Here's a water jet. Looks like. Yeah, it's definitely a water jet. So cut on a water jet, similar. So we'll start designing it soon because we need to get ready to go, get ready to have it start being cut on the water jet. As I need to also start working on the Kickstarter page, so I could get ready once I'm done with the prototype, put it on there, shoot a video for it, and get it out there. I don't have a lot of time, got less than a month, so I need to get going on it. Shouldn't take very long to design because almost every single one of these blades are the same, except for what you're gonna have is you're gonna have to rotate the inside square in order to get it to have this progressive thing. That's why it's sometimes better to have a hex, because you could just rotate a little bit. I just have them constantly rotate, but I'm gonna have to do the calculations on how much twist each one needs to not engage all at once, so that it's more even as far as only having one tooth engage at once rather than a whole bunch of them engage at once. Alright, that is pretty much it for this video. That's about all I want to talk about. So again, the product's called the Reclaimer. It's a shredder, 6x6 inch, 3 inches tall. And the idea why I was going to be 6x6 is I wanted to be able to at least shred a milk jug, which is 5.5 by 5.5 or whatever. So be able to shred at least that, and pretty much most prints that you throw at it, most 3D prints. Another thing I'm also going to sell it as is if you want to do organic, like this guy, if you want to do organic shredding with it. So what I mean by that is shredding like some of the stuff that comes off of your kitchen, out of your kitchen, some waste food. That if you're a composter, the idea that your compost is a lot more efficient if it's shredded to very small sizes. You get a lot more density in one place, and a lot more heat and a lot more breakdown. So increase the density by taking stuff out of your kitchen, shredding it, throwing it in your compost bin. So either plastic or it's called the Reclaimer. So the idea is when you throw something in there, you're trying to reuse it. So whatever it has strength to cut, and shred, you could use it for. Alright, that's pretty much it for this video. I'd like to thank you guys for watching. If you like this video, please subscribe for more videos like it in this series and other series as well. I'll see you guys next video. Thanks for watching. Take it easy. Peace. Catch you guys in the next video in this series. Later.